Hi everyone, I am Nobuhiro Ito, a past exec committee of this league, RoboCup Rescue Simulation League. I have been a member of this league since 1999, so I have been involved with this league since before it officially started. At first, I participated to Soccer Simulation League from first RoboCup and studied cooperative protocols and multi-agent models. But I wanted to increase another application for my study, so I joined the Rescue Simulation League. At that time, Japan experienced the Great Hanshin Awaji earthquake, a major earthquake that hit directly under the urban city and caused serious problems. It was one of the reasons why I chose RoboCup Rescue. Since then, serious natural disasters have occurred in many parts of the world, each time making us think about the mission of RoboCup Rescue Simulation League. Today, I'd like to take a moment to look back at the early days of the league and talk about the challenges of RoboCup Rescue and what to expect in the future. RoboCup has become a significant AI and robotics project, attracting more than 3,000 participants from over 40 countries. One of the objectives of RoboCup is to return the result of AI and robotics research to society through research on soccer. So, RoboCup Rescue is along such an objective, although it is not soccer competition. RoboCup started in 1997 for soccer. And this is a 3D soccer simulation. And added Rescue Simulation League in 2001. After that, the other leagues gradually started. The rescue started in a way that reflected the research result of soccer. This table shows major differences between RoboCup soccer and rescue. To start with a simple explanation about the number of agents, soccer is an 11-on-11 game, while rescue is a game in which an unspecified number of rescue teams perform rescue operations. As for the type of agents in soccer, there are positions such as forward, midfielder, defender, goalkeepers, etc. In rescue, there are many types of agents such as fire brigades, ambulance teams, police forces, etc. and their respective command centers, fire offices, police offices, and ambulance centers, and so on. About abilities of agents. In soccer, the ability of agents are roughly the same, with exception of the goalkeepers. Whereas in rescue, each type of agent has different abilities. Furthermore, control. While soccer is essentially a decentralized control in which players operate individually, rescue uses a combination of centralized control by a command center and decentralized control as a disaster site. In other words, rescue is a more complex problem than soccer. It implies that the result of soccer can't be applied directly to rescue. Now, I will show you a promotion movie in early days of RoboCup Rescue around 2000. I feel that this movie depicts the goal of the league when it was just starting out.
ジオ技術研究所前輪はロボカップレスキューに協賛し、3次元地図データの供給を通して共同研究を行ってまいります。それではロボットと3次元地図データの関わりをご覧ください。
地下街入り口確認。
地図データ読み込み開始。データ照合開始。要救護者発見。報告開始。
ロボットと3次元地図データが融合することで、建物の倒壊状況を把握し、災害状況を取得することが可能となります。また、人の入ることのできない危険度の高い倒壊現場において、被災者情報収集などの救助支援活動が期待されます。今後の活躍をご期待ください。
This movie shows how an urban disaster relief simulation and disaster relief management system work together with robot and human disaster relief teams to accomplish disaster relief. I searched for old movies, but I think watching them now will make us think again. Next, talk about RoboCup Rescue history. RoboCup Rescue began as a simulation league demonstrated in Melbourne 2000 and officially launched in Seattle in 2001. The upper image is an image of agent competition, and lower image is a 3D version of it. The original competition was to simulate city-wide rescue strategies. At first, it operated only in a small area of 1.5 kilometers square, but gradually took on its current form, operating in a 3 kilometer square area. The Robot League, the Real Robot League was demonstrated in Seattle 2000, RoboCup 2001 and has been an official competition since then. The Robot League initially aimed to find victims stuck in collapsed buildings, and after that, the virtual robot competition, a simulation of the Real Robot League, has been recorded since 2006. This is the roadmap shown by Professor Tadokoro, who is one of keynote speakers in this RoboCup 2022 symposium in ICRA 2000. The final goal was introduction of intelligent, mighty rescue robot like Japanese animations and contemporary Thunderbirds for search and rescue. The idea behind this roadmap seemed to be to link the Rescue Simulation League with the Real Robot League. From this perspective, it may be necessary in the future to integrate or link rescue agent competitions and virtual robot competitions, which are currently separated. Of course, there have been several attempts to link and integrate agent competitions and virtual robot competitions, but so far they have not been successful. I hope it for the future. I'd like to talk about disaster relief problem. I have mainly participated in the agent competitions, so I will focus on the agent competitions. The agent competition simulates disaster relief activities for approximately 5 hours after the occurrence of earthquake directly under an urban area. The earthquake causes fires, collapsed buildings, and collapsed roads in the affected areas, and the civilians who lived there headed for evacuation places. At this time, the rescue platoon must clear the main road by repairing blocked roads, and also extinguish the fire for the smooth evacuation of civilians. Furthermore, if there are people buried in buildings, they must be rescued and transported to a hospital or evacuation places. The key here is a distributed heterogeneous agent cooperation strategy. This problem includes issues such as information gathering and sharing, multitask allocation, cooperative protocols, and so on. Disaster relief issues are complex and also complex in their structure, so we must address this issue step by step. The current RoboCup Rescue Simulation League addresses these issues. This RRS means RoboCup Rescue Simulation. This multitask allocation is a very important issue in Rescue Simulation League. The information sharing, the group formation, clustering, and path planning are related with each other. The structure between these problems also depends on the modeling of problem, and this structure complicates the problem. The conditions, such as the combination of decentralized and centralized control, partial observability of environments, and communication limitations must also be considered. The problem is complex, but I believe it is an important issue when applying AI technology to the real world. In that sense, it would be very good if the League could systematically and gradually lead us to a solution. However, it will not be easy. This is major challenges in Rescue Simulation League. These major challenges have two types of challenges: project challenges and infrastructure challenges. The project challenges is the main theme of each year in the league. The early days of the league, the challenges was to solve rescue tasks such as extinguishing fires, repairing roads, and rescuing civilians using a combination of centralized and decentralized control. To facilitate this challenge, competitions are held with conditions for communication between agents as full communication, partial communication, and no communication. Currently, we are trying to focus on civilian rescue tasks such as deciding which rescued civilians should be transported to which evacuation site, taking into account the number of available beds in the evacuation site. The infrastructure challenges are promote league researches and management. These four challenges were given by trustees, and we have already achieved them. Last one is as talked in previous slide. Through these challenges, we have tried solving the disaster relief problem until now. I think that all challenges are very important. I would like to introduce some of initiatives I've been working on, starting with the next slide. At first, I want to talk about Agent Development Framework, ADF. This Agent Development Framework, ADF, is a mechanism that provides both component sharing and reusability as described in previous slide. The cost of developing a rescue agent, including the definition of algorithms and the communication protocols to solve such problems, is not small. This is an example of an implementation of agent program. Each agent needs these functions and definitions. Of course, the agent developed by two teams, for example, Team A and Team B, are not compatible. So even if they solve the same problems, they are difficult to reuse. Furthermore, it is not possible to use an agent from Team A and an agent from Team B at the same time. Therefore, a rescue agent needed to have a fire brigade agent, police force agent, and ambulance team's agent, but it was also difficult for newcomer teams to develop only one type of agent and use existing agent for the others. So ADF provides a common protocol and also provides algorithm modules for disaster relief problems, allowing not only the simultaneous use of multiple teams, but also the exchanges of algorithm modules between teams. This has dramatically improved code reusability and development efficiency. When used in research, the code is less modified and easier to compare. The tutorials on the use of ADF will be held today, and I hope that you will attend and get a feel for it. In addition, we have developed and provide a simulation management system called RRS Oasis, which allows users to easily change maps and simulation conditions, manage runs, and save results when using the rescue simulator for research. The system can also manage parallel execution of simulations that require the use of many computers at the same time. Last year, RRS Oasis was extended to the public cloud and now available on Amazon Web Services. We hope that this system will be of great use in your research. Next, DCOP module for rescue simulation. Several researchers in the League have proposed approaches to solving the task allocation problem in rescue as a distributed constraint optimization problem, DCOP. Therefore, implementation using rescue simulation as a benchmark for DCOP have been proposed in the past. But unfortunately, their development has been terminated. Behind this background, we have proposed a new implementation and made it easily available in the ADF. DCOP is a problem under ideal conditions such as static environment that doesn't change along time and where all information is available. We hope that providing this problem on RoboCup Rescue as a partially observable problem in a dynamical environment that changes along time, which is closer to reality, will lead to new research. In August 2019, the tutorial on multi-agent distributed constraint optimization problem was held. In this view, I guess that the DCOP in rescue is a good challenge. We would like to continue DCOP researches with this module and provide this module continuously. Next, 3D viewers for RRS. Visualization of rescue simulation is another important issue. This is because RoboCup is an event, and its value can be greatly enhanced if the research results can be effectively presented to the general public visitors and researchers who attend the event. Unfortunately, this movie is in Japanese, but English message versions are also available in this viewer. This viewer provides an explanation for how to understand the simulation before starting simulations using onboarding system. When we prepare the key point of scenario, we can insert it too. And this viewer adopts the comparison view of two teams. In the view, spectators can watch a simulation at the same location and the same timing in the simulation. From this point of view, we believe that this idea can be applied to a visualization system for development. Now we are developing the improved version for developers and public respectively. We will show you them next year. We can change angle and locations and check the detail of movement of agents and behavior of agents. Actually, I used this viewer in RCAP 2021 and broadcast and live of simulations on YouTube. It is very good for public to understand the situation of simulations. Until this slide, I have introduced the current challenges of the league, what I have been working on, and what I would like to work on in the future. Finally, I'd like to talk about my expectation for the future of the league in the next slide. At last, I will talk about expectation for the future of our league. First, I'd like to talk about linking RoboCup Rescue with other competitions. It is important to be aware of how the result of our project will be used in the end, and to have concepts that take into account their relationships even if the competitions are separate. So, we should consider collaborations between agent and virtual robot competition for the future. The second, contribution to the real world. Making a challenge an activity needed in the actual disaster area and the field is effective. So, I think that current challenge in agent competition is very good. Furthermore, not only the scenario immediately after the disaster, but also the scenario after a while after the disaster is also good. Finally, it is the academic challenges. Unfortunately, there are not many participants in the league, so activity take on academic challenges and promote the league. From this view, we always provide new challenges for participants and help them to appeal our results. The RoboCup Rescue Simulation League and project is very significant and deserves more attention. I hope this project and the league will develop further. Thank you for your attention.